Welcome back, friends. Today we're diving into construction technologies that have reached an entirely new level of innovation and performance. From smarter materials to groundbreaking machines, these advancements are transforming how the world builds. Imagine improving concrete so it becomes tougher, more durable, and far less likely to crack under stress. That's exactly what SikaFiber reinforced concrete is designed to do by mixing tiny synthetic or steel fibers directly into the concrete. These fibers spread evenly throughout the mix, creating a three-dimensional reinforcement network that helps solve concrete's biggest weakness, its tendency to crack under tension. By adding SikaFiber, the concrete gains better tensile strength, greater flexibility, and improved resistance to impact and abrasion. The fibers come in different types, from fine microfibers that control early shrinkage cracks to stronger macrofibers and steel fibers that boost structural performance in heavy-duty areas. One example is SikaFiber NovaMesh 950, a blend of both micro and macro fibers that can even replace traditional steel mesh in floors and pavements. This reinforced concrete is now used in industrial floors, roadways, tunnels, runways, precast panels, and many other demanding applications. It also helps construction teams save time by reducing the work needed to cut and place steel reinforcement. However, proper mixing and the correct dosage are important to ensure the fibers work as intended. With the help of Sika's engineering tools, builders can choose the right amount of fiber for their slab thickness and load requirements. Overall, SikaFiber reinforced concrete offers a modern solution for stronger, longer-lasting structures across many types of construction. When it comes to repairing damaged concrete or brick surfaces, Tito solution staples offer a simple and reliable way to strengthen cracked areas. These heavy-duty metal staples are designed to sit across a break in the surface, helping to lock both sides together and prevent the crack from spreading. The company makes them in different sizes, and they're sold in packs of 5 or 10, depending on the model. One of the versions is recommended for cracks between 0.04 and 0.2 inches wide, giving users a clear idea of when to use it. Installation starts by cutting a small groove across the crack, placing each end of the staple into opposite sides, and then filling the area with mortar or epoxy. Once everything is set, the staple works together with the bonding material to create a stronger and more stable repair. This method follows the well-known crack stitching technique used in the construction industry. Because the staples add physical reinforcement, they can handle movement and stress that simple fillers alone cannot manage. And depending on the length and severity of the damage, multiple staples can be spaced along the crack to restore strength and durability to the surface. Now let's look at a large on-site 3D concrete printer designed to build full-size structures quickly and with high accuracy. This machine is called the Maxi printer, and it uses a foldable mobile frame that can be set up on a construction site in less than 15 minutes. Once deployed, it can print walls, rooms, or even small buildings within a build area of about 12 by 12 by 7 meters. The printer works by extruding a special concrete mix through a nozzle, while the pump and hose system deliver material automatically. One of its most useful features is its compact transport size, allowing it to be moved easily through tight spaces or shipped in a standard 20-foot container. The Maxi printer also includes its own software, which prepares 3D models and monitors pump pressure, nozzle speed, and printing conditions in real time. Users can adjust layer heights and widths to match the material and design they want. It is built to handle outdoor conditions, operating safely between -5 degrees Celsius and 50 degrees Celsius, and resisting winds up to 60 kilometers per hour. As a complete package, it comes with a pump, silo kit, control screen, and full operator training. Overall, the Maxi printer gives builders a fast and flexible way to print strong concrete structures directly on site, reducing formwork, labor, and construction time. Meet the ACETube dewatering system, a smart solution designed to handle the messy challenge of separating water from sludge, sediment, and other wet materials. Instead of relying on large drying beds or expensive filter press machines, this system uses giant fabric tubes made from strong woven polypropylene that let water escape while keeping solid particles securely inside. During operation, dredged sediment or sludge is pumped into the tube, often with added polymers to help the solids settle faster. As the tube fills, clean water drains out through the engineered textile, and the material inside slowly dries and shrinks, sometimes reducing its volume by up to 90%. These tubes can be incredibly large, some measuring over 69 feet around and nearly 100 feet long, allowing them to hold far more material than traditional methods. Because the fabric resists sunlight, chemicals, and abrasion, the tubes can be used safely in harsh environments like harbors, reservoirs, mining sites, and farms. Their small installation footprint makes them easy to place on prepared ground or inside containment areas, even in tight locations. Once full, the tubes can be stacked, stored, or opened later to remove the dried solids for reuse or disposal. By offering fast drainage, efficient containment, and flexible sizing, the ACETube dewatering system provides an environmentally friendly and cost-effective way to manage large volumes of dredged or waste material. Tilt-up concrete construction is a building method where large concrete wall panels are cast horizontally on the job site, usually on a concrete slab or temporary casting surface, and then lifted into their vertical position using cranes. The process begins with preparing the slab, placing formwork, and installing steel reinforcement and embedded items like window openings, sleeves, and connection inserts. Once the concrete is poured and cured, each panel is lifted, or tilted up, by a crane and set onto its foundation footings. After bracing the panels temporarily, workers connect them at the base and along the joints to create the structure's exterior envelope. This technique is popular for warehouses, distribution centers, schools, office buildings, and retail stores because it provides fast construction, excellent durability, and cost efficiency on large open-area sites. Tilt-up panels can reach heights of more than 30 meters and often incorporate insulation layers, architectural finishes, or textured surfaces directly into the casting process. Because the panels are made on site, transportation costs are lower, and the method allows for rapid enclosure of large buildings. Additional benefits include high fire resistance, low maintenance requirements, and strong energy performance when insulated sandwich panels are used. Overall, tilt-up concrete construction combines speed, structural strength, and design flexibility, making it one of the most widely used modern techniques for medium to large-scale commercial and industrial buildings. When it comes to producing high-quality concrete pipes with speed and consistency, the Besser Apex Series BiDi machine stands out as an advanced and highly efficient solution. Designed around a proven bi-directional roller head compaction system, it delivers excellent concrete consolidation, strong wire-to-concrete bonding, and a smooth, professional finish on every pipe. Its redesigned pit shell uses a smaller footprint, about 15% more compact than earlier models, making installation faster and ideal for plants with limited space. The machine also includes a smaller turntable for quicker rotation and a rapid hydraulic crosshead drop that cuts cycle times, boosting hourly output by up to 10%. Precision is enhanced through direct drive variable frequency controls, which keep mold positioning accurate and consistent. The Apex lineup supports a wide range of pipe diameters from 8 inches all the way up to 84 inches, with pipe lengths reaching up to 12 feet depending on the model. Operators benefit from easy installation, smoother daily operation, and reduced maintenance thanks to upgraded automation features like HMI controls and remote monitoring plants using the Apex. BiDi report more uniform products and the ability to standardize equipment and parts across production lines. Overall, this modern machine delivers the performance, reliability, and scalability needed for today's demanding concrete infrastructure projects. Meet the XCMG XGL 3300-220S, a new generation tower crane built to handle the massive size of today's wind turbines. Designed for ultra-heavy lifting, it can raise loads of up to 220 tons to heights of more than 220 meters, making it suitable for 10 megawatt and even 15 megawatt turbine installations. In one real project, it lifted a 150-ton nacelle to 160 meters with millimeter-level precision, showing how accurate and stable it is even under tough conditions. The crane is engineered to keep working safely in high winds, operating in level 6 wind speeds and withstanding level 10 gales when standing still. Its compact 30 by 65 meter setup area and modular transport system make it easy to assemble and move, even in remote wind farm locations. With a lifting speed of about 6 meters per minute and micro motion control as fine as 5 millimeters per second, it places giant components exactly where they need to be. The crane can also be installed with minimal foundations, reducing site preparation costs and speeding up project timelines. By enabling the safe and efficient installation of very large turbines, the XGL 3300-220S is helping push renewable energy to new heights, literally and technologically. Next, we have the Redi-Rock wall system, a modular retaining wall solution designed to make large, durable walls faster and easier to build. Each wall is made from massive, interlocking concrete blocks that fit together like oversized building blocks, allowing contractors to create gravity walls, reinforced walls, or freestanding structures with impressive strength. The blocks are precast with deep stone textures, such as ledgestone, cobblestone, or limestone, so they look like natural rock while offering the long-lasting durability of concrete. Because the blocks are large and mostly dry-stacked, installation requires far less labor than traditional retaining wall methods. The system supports a wide range of wall heights, with gravity blocks used for moderate walls and reinforced versions paired with geogrid for taller or heavily loaded applications. Designers also benefit from software tools and engineering support that help check stability, drainage, and load requirements to meet local standards. Since Redi-Rock is produced by licensed manufacturers worldwide, block size and shape remain consistent, no matter where the project is located. These walls are commonly used for road embankments, land development, utilities, waterfronts, and landscaping, where appearance matters. With strong structural performance, quick installation, and attractive textures, Redi-Rock offers a reliable and visually appealing solution for modern retaining wall construction. If you've ever seen a hillside start to crumble after heavy rain, you know how dangerous slope failure can be. That's where the Terra-Lock slope stabilization system steps in with a smarter and more reliable solution. This system uses deep-set ground anchors that lock into stable soil or rock, helping hold the entire slope in place and stop it from slipping. On the surface, special reinforcement mats protect the soil from erosion while supporting vegetation growth, creating a natural, self-healing layer over time. Each anchor can handle loads of up to 32.5 kilonewtons, giving the system enough strength to stabilize steep slopes with far less excavation than traditional methods like riprap or concrete walls. Installation is quick and efficient because the components are lightweight and require minimal heavy machinery. The materials are also corrosion resistant, making them ideal for wet environments like riversides, channels, and coastal embankments. Terra-Lock is versatile enough for road embankments, spillways, hillsides, and even environmentally sensitive areas. By combining soil anchoring with erosion control, it provides a long-lasting, eco-friendly way to strengthen slopes and prevent future damage. This is the Stresslite precast concrete house system, a modern way of building homes that focuses on speed, strength, and long-term performance. Instead of constructing walls and floors piece by piece on site, This method uses large precast concrete panels that are manufactured in a controlled factory environment for maximum quality. Each panel is engineered for durability, thermal efficiency, moisture resistance, and fire safety, giving the finished home far better performance than many traditional block or timber frame structures. Once delivered to the site, these panels are lifted into place with a crane and assembled quickly, reducing weather delays and cutting down on wet construction work. Because the elements are produced with precise tolerances, they fit together cleanly, creating strong connections and a solid structure. The system also supports a wide range of architectural styles and insulation options, so homeowners can customize the look while still benefiting from the advantages of precast concrete. Its thermal mass helps regulate indoor temperatures, improving comfort and energy efficiency over time. With less maintenance required and a longer lifespan, Stresslite homes are well suited for demanding climates or modern building standards. Overall, the Stresslite precast system combines factory precision with fast on-site assembly to deliver high-quality homes that are built smarter and last longer. That's all for today, friends. Thanks for exploring these next-level construction technologies with us. Until next time, keep learning, stay inspired, and watch how innovation continues to reshape the world around us.